In this video, we'll find the n, n+1, and n+2 figures for alternating black and red figures. Our question is, given the first four figures of sequence 2, analyze the figures and give the n, n+1, and n+2 figures along with their symbolic forms, and then give the number of each type of piece in each figure. We'll use our three-step pattern analysis. So here's our analysis. You can see that across the top, not including the corners, we have the figure number, and also on the sides and on the bottom, again excluding the corners. And you can see the switches, black, red, black, red. Then the corners for the odd figures are all red tiles, and for the even figures are all black tiles. And then the diagonal is the figure number, red for the odd figures and black for the even figures. So the pattern is the same, but the colors are reversed for the alternating figures. So you can see the number count is there. It's 4 times the figure number minus 1 minus 4 for figure 1, and then looking at figure 3, which is also odd, it's 4 times the figure number 3, that's the black tiles, minus 3, that's the 3 red tiles diagonal, and minus 4, that's the 4 corner tiles. And then looking at the even, it's 4 times minus 2, because those are red, plus 2, that's black, plus 4, those 4 black corners. And then for the fourth one, which is also even, 4 times minus 4, because they're red. There's various ways to write that, but that works. And then plus 4 for the middle diagonal figure number, and then 4 for the 4 corner black tiles. So for odd, it's 4 times the figure number plus the figure number in red, plus 4 red tiles. And for even, it's 4 times the figure number in red, plus the figure number, plus 4 black tiles. So T of n when n is odd is 4n minus 4, which simplifies to 3n minus 4. And T of n when n is even is negative 4n plus n plus 4, which simplifies to negative 3n plus 4. And you can see they're the same, the signs are switched, which makes sense because the colors are switched. Now we need to make our nth figures. So we have the n odd figure and the n even figure. So we have black around the outside and red corners and a red diagonal for odd. Let's look at our figures. Yes, that matches. And then for even, we have red around the outside and then black corners and a black diagonal. So the opposite colors. And those are both described there. So for T of n for odd, 3n minus 4 is the simplified version. T of n for even, negative 3n plus 4. And notice that the strips switch. So it's 4 black end strips and 1 red end strip and 4 red tiles when n is odd. And the opposite colors, 1 black end strip, 4 red end strips, and 4 black tiles for when n is even. The even and the odd figures have the same structure, but the colors are switched. Now, let's look at the n+1 and n+2 figures. This gets a little tricky because the colors switch. But if you think about growing the figure and just switching the colors, it makes it easier. When n is odd, n+1 will be even, and then n+2 will be odd again. And so you can create simplified versions of your equations. But when we work on this, and we'll do some problems with this in subsequent videos, it will probably be easier to use the algebra piece figures and not get bogged down in symbolic forms. So, and then you can see what happens when n is even. When n is even, we do the exact same thing. We just switch the colors. We start with red around the outside and black corners, then we switch, and then we switch again. So if n is even, n plus 1 will be odd, and n plus 2 will be even. So let's check our work. We have n odd and n even, and that matches our figures. We just need to pay attention how many figure numbers we have, how many tiles we have, and which color they are. And then when we look at our chart, although a specific example is not a proof, it's a really good check to make sure that you've done your figures correctly. And in this case, when n is odd, we'll use 1 as an example. Notice when we put in our fourth line here, t of 1 plus 1 is t of 2, and we put it into -3, 2 plus 4, we're using the even function, and that worked out. But when we put it in with our original n equals 1 in this simplified version that we have from this n plus 1 even here, we also get -2. And in the same way, when we add 2, we'll get the same numbers. We can also check when we look here, just to make sure that we haven't made an egregious error, what happens when we plug in 2. So all together, we have 2 sets of answers. We have when n is odd, then n plus 1 will be even, and n plus 2 is odd again. We have our symbolic formulas, and we just have a list of which types of pieces we have. 4 black end strips, no black tiles, 1 red end strip, and 4 red tiles for figure n when n is odd. Then when figure n plus 1, everything switches. So now we have 1 black end strip and 4 red tiles. And now we have 5 black tiles. Why is that? That's the 4 corners, and then the end strip in the middle has grown by 1. And we have 4 red tiles. And why is that? It's because the 4 red strips here have grown by 1. And then n plus 2 odd. So we have 4 black end strips because we're back to the odd figure. So those are them. And we have 8 black tiles. Why is that? It's because each of those end strips has grown by 2, and there are 4 of them. And then 1 red end strip and 6 red tiles. And why is that? Because we have 2 here from the red strip growing, and then our 4 corners. And we have a similar thing when n is even. So we start with red and on the outside, and then black, and then red again. And we carefully keep track of our strips. 1 black strip and 4 black tiles for the corners, 4 red strips, and no red tiles. Notice when we go up 2 here, we'll still have 1 black strip. We'll now have 6 black tiles because we have 4 on the corners, and then that black end strip in the middle has grown by 2. And we'll still have 4 red end strips, and then each one of those has grown by 2. So we'll have 8 red tiles. And again, we'll get more practice with this in subsequent videos when we work with figures n and n plus 2 with alternating tile figure sequences.